Hello everyone, I am Asha, Assistant Professor in Artificial Intelligence and Data Science. So welcome to this video series on data mining and data warehousing, where we will learn how large amount of data are stored, organized and converted into useful knowledge. This series is designed especially for ADS students with simple explanations, real-time examples and exam-oriented coverage. Let us start our journey of turning data into insights. So in cluster analysis part 1 video, we have seen what is meant by cluster analysis and why we need it, and what are the different types of data we use and what are the properties of clusters, etc. So in this video, we are going to learn about the types or methods of clustering. So we have 4 methods. So the first one is partitioning method. What is partitioning? See, partitioning is nothing but dividing. So what we are going to divide here? Data set. Okay. So when we come into a definition, a partitioning method divides a data set into exactly K clusters. K is nothing but it will be specified in advance by the user. So each object, that is a data point, belongs to exactly one cluster. There is no overlapping, no ambiguity. So think of like dividing a class of 60 students into exactly 3 groups for a project. Each student goes into one and only one group. Okay, so this is partitioning method. What are the key characteristics? Number of clusters K is specified in advance. You must decide K before running the algorithm. Iterative process. The algorithm repeatedly reassigns the data points to clusters and update cluster center until stability is reached. So this is efficient for large data sets, relatively fast compared to other methods. That is hierarchical, the next method what we are going to learn. Best suited for spherical or compact clusters. And it works best when clusters are roughly round shaped. They should be round shaped and similar in size. So what is the general process? Initialize, assign, update and repeat. So we have 4 steps. First step is initialize K cluster centers. You are initializing K cluster centers. Next one, assign. Assign points to nearest center. Third one, update centers. And fourth one, repeat until no change. So this is a procedure or iteration which you are going to repeat. Popular algorithms, 2 algorithms are there. K-means clustering, K-Medoids clustering. So in K-means clustering, it uses a mean, that is average of all points in a cluster as the center. It works best with numerical data. Then what is K-Medoid? It uses an actual data point as a center. It works with any data type, including categorical and mixed data. We have seen in the last video, right? Part 1, data types. So not only numerical, K-Medoids can be dealt with categorical as well as mixed data. So why we must specify the K in advance, the value of K? This is one of the biggest limitations of partitioning method. If you don't know how many groups exist in your data, you have to guess or use techniques like elbow method to find the best K. So always ask how many groups do I expect in my data. So I can give you one real world analogy. Imagine a university wants to divide 1,000 alumni into 5 donation groups based on giving history and income. So they use K-means with K equal to 5. How many groups? 5 donation groups. So K equal to 5. Each alum belongs to exactly one group. The marketing team then sends targeted fundraising emails to each group. I hope now you got clear idea. K-means is the most popular and widely used clustering algorithm. It divides data into K clusters by minimizing the distance between data points and their cluster centers, that is centroids. The word means, K-means, the word means refers to the average or mean of all data points in a cluster, which becomes the centroid. So step-by-step algorithm. First step is choose a number of clusters. The user decides how many clusters to find. This is a critical decision. Too few clusters may overgeneralize. For example, grouping very different people together. Too many clusters may oversegment every person in their own group. Okay, so use domain knowledge or the ELBO method to choose K wisely. This is first step. What is step 2? Initialize K centroids randomly. That is, you have to place K random points in the data space. These are the starting cluster centers. The result of K-means can vary based on where centroids are initialized. This is why we sometimes run the algorithm multiple times with different initializations. Okay. Then step 3. Assign data points to nearest centroid. For each data point, calculate its distance to every centroid. Assign it to the cluster of the nearest centroid. Distance is typically measured using Euclidean distance. D equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so you can pronounce it as Euclidean or Euclidean. So it depends. Next step 4, recalculate the centroid. After all the points are assigned, compute the new centroid of each cluster by taking the average of all the points in the cluster. Okay, so the centroid moves to the geometric center. Next, step 5. Repeat until convergence. That is, go back to step 3. Reassign the points based on the updated centroid. Keep repeating the above two steps, step 3 and step 4, until no data point changes its cluster. That means both the columns should be same. This state is called convergence. So the centroids are stabilized. K-Medoids clustering. So what is the idea? It uses actual data points, that is the medoids, as centers. And advantages, it handles outliers better, it works with any data type, and more interpretable. So when we compare K-means and K-Medoids, K-means centroid and K-Medoids medoid. So use when data has no noise or mixed types. So when I take a real-time example, choose K-Medoids when your data set has outliers or noise. Your data is non-numeric or mixed. You need the cluster representative to be an actual real-world entity, a real customer, a real document. So choose K-means when speed is a priority and data is clean numeric data. Okay, so K-Medoid. K-Medoid is a variation of K-means with one crucial difference. Instead of using a computed average as the cluster, K-Medoid uses an actual data point from the data set as the cluster representative. That is a major difference between K-means and K-Medoids. So this representative is called a medoid. The medoid is the most centrally located object in a cluster. The point that minimizes the total distance to all other points in the cluster. So main characteristics is it uses real data points as center. It works with any distance metric, and cluster centers are always interpretable. That means you can look at the medoid and say this is the most representative customer or patient or product in this group. So common application, it uses mixed data type. So there is numerical plus categorical, noisy data sets with outliers, and when interpretable, center points. For example, selecting the most representative product for each customer segment. So you should know when to choose K-Medoid and when to choose K-means. Next is hierarchical clustering. So hierarchical clustering builds a tree-like structure of clusters, tree, and that structure is called as a dendrogram, dendro. Unlike partitioning method, which need to specify K in advance, hierarchical clustering creates a complete hierarchy of grouping at all levels. You can cut the dendrogram at any level to get your desired number of clusters. Think of it like a family tree. At the top, everyone in one big family. At the bottom, everyone is an individual. Okay, so what is dendrogram? A dendrogram is a tree diagram that shows the order of merging or splitting. So the y-axis height represents the distance or dissimilarity at which each clusters are merged. The x-axis represents individual data points. A horizontal cut of any height on the dendrogram gives you a specific number of clusters. So we have two approaches over here. One is agglomerative, that is nothing but bottom-up approach. Second one is divisive, that is nothing but top-down approach. So agglomerative means this is the most common approach, starts with each data point as its own individual cluster. Then it merges the two closest cluster together. First it starts with individual cluster, then merges the cluster which are closest to each other. Then it will repeat until all the points are in one single cluster. So the dendrogram grows upward from leaves to root. That's why it is bottom-up approach. Okay. Divisive, it is top-down. Starts with all data points in one single large cluster. Recursively split the cluster. Divisive, split the cluster into smaller ones. So it continues until each point is its own cluster. So the dendrogram grows downward from root to leaves. That's why it is top-down approach. Okay. So this is the biggest advantage of hierarchical clustering over K-means. You don't need to know how many clusters you want beforehand. You build the full tree first, then decide where to cut based on the dendrogram visualization. Agglomerative clustering. So what are the steps? Step 1. Start with each point as a cluster. Step 2. Find closest clusters. Step 3. Merge them. Step 4. Repeat until one cluster remains. So bottom-up hierarchical approach is agglomerative, right? So this clustering builds clusters from the ground up. It starts with every single data point as its own cluster and progressively merges the closest pair. So the process continues until all points are merged into one master cluster. The merging history is captured in the dendrogram. Okay. So what are the steps? We have to start with individual point. We have to calculate the distance between all cluster pairs. Then merge the closest two clusters and repeat until only one cluster remains. I'll give you one classroom analogy for this. Imagine seating 6 students in a classroom and grouping them by similarity. What is step 1? 6 students, so 6 groups. Step 2, find the 2 most similar students, say A and B are best friends. Merge them. Now how many groups? 5 groups. Step 3, find the next closest pair. Say suppose C and D sit next to each other. Merge them. So now how many groups? 4 groups. Continue until everyone is in one group. So the order of merging is your dendrogram. So agglomerative clustering has a time complexity of O of n square log n in its basic form, making it slow for very large data set. For small to medium database, I mean, data set, it's okay. It works very well. But for a large data set, you have to consider mini batch or approximate hierarchical method. Density-based clustering. So what is the idea here? Clusters are nothing but dense regions. Then sparse regions, noise. Okay? So in density-based clustering, clusters are formed based on dense regions of data points. Where the data points are more, that is dense region. A cluster is a region where data points are tightly packed together, separated from other clusters by regions of low density. So what is the core idea here? Where there are many points close together, that is a cluster. Where there are few points are spread out, that is noise or boundary or outlier. Okay? So popular algorithm is DBSCAN. DBSCAN is nothing but density-based spatial clustering of application with noise. So what are the key characteristics here? It finds a cluster of arbitrary shape. That is, unlike K-means means only spherical. Density-based method can discover clusters shaped like spiral, crescents, rings, or any irregular shape. See, K-mean means only spherical. That is clusters, spherical cluster. But density-based means any shape. No need to specify the number of clusters in advance here. The algorithm finds clusters automatically based on data density. So you only specify two parameters. What is that? One is neighborhood radius, another one is minimum points. So it automatically identifies the noise and outliers. Points that don't belong to any dense region are labeled as noise. This is a powerful feature for fraud detection and anomaly detection. So if you compare with K-means and density means, main thing is it's not depending on the shape, any shape. K-means is only spherical. Here it can be of anything. And in K-means you have to specify the K, but here no need to specify the K. And in K-means there is no outlier, no noise, but here it handles the noise. Okay? DBSCAN algorithm. What is the full name? Density-based spatial clustering of applications with noise. So here we will be dealing with two key parameters. One is the epsilon or eps. Another one is the mean points. So three types of points in DBSCAN. One is core point, border point, and noise point. Okay. So how it works? Let us see step by step. First step is what? It picks any unvisited point. Find all points within epsilon distance. And if count is greater than or equal to main point, then that particular point is a core point. So start a new cluster, expand it by checking all neighbors of P. So if count is reverse, that is if count is less than main points, then P is temporarily labeled noise. That is, it becomes outlier. Repeat for all unvisited points. So what are the key features? It does not require predefined number of clusters. It finds arbitrary shaped clusters and it detects noise and outliers automatically. Robust to different cluster shapes and densities. Okay. I can give you an example like for fraud detection how it is used. A bank has millions of daily transactions. Normal transactions cluster densely around a typical spending pattern like small amount, local merchant. But fraudulent transactions are sparse, isolated points far from any dense cluster. So DBSCAN labels these as noise, which are exactly the fraud cases the bank needs to investigate. Grid-based. Let me start with a real-world application. Take city traffic analysis. Divide a city map into a grid of 1 kilometer into 1 kilometer cells. So count vehicles in each cell every minute. Cells with many vehicles. So that is what? Traffic hotspots. Okay, that is cluster. Cells with few vehicles, that means empty roads, no cluster. The grid processes millions of GPS pins in real time without checking every vehicle pair. So now let us see the definition. Like grid-based methods divide the entire data space into a finite number of rectangular grid cells, forming a grid structure. So clustering is then performed on the grid cells rather than on individual data points. So how it works? The data space is partitioned into a grid, like a spreadsheet of cells. Each grid cell is assigned a density value. How many data points fall within that cell? Cells with high density are considered part of clusters. Cells with low density are sparse regions or noise. So adjacent high density cells are merged to form clusters. So what are the key features? They are fast processing time, efficient to large data sets, and it is suitable for real-time applications, and independent of number of data points. So main advantages, reduced computational complexity, that is O of n square, time complexity. Then scalable performance, memory is efficient, and quick cluster identification. See, here we use one algorithm called sting algorithm. Okay, what is that? Sting algorithm. So sting is nothing but statistical information grid. So sting organizes data into a hierarchy of grid cells at different resolutions, like levels. High level cells cover large areas and low level cells are smaller and more precise. So sting processes queries top down through the hierarchy, quickly eliminating sparse cells and focusing computation on dense regions. That is very important. Outlier analysis. What is outliers? Very different data points. And what are the methods? Statistical method, distance-based method, density-based method, and a machine learning method. And what are the causes? Errors, fraud, then rare events. So outliers, they are also called anomalies or data points that significantly deviate from the majority of data in a data set. They are the odd ones out. They don't fit the expected pattern. Okay. So the process of identifying these unusual data points, that is outlier analysis. We can also name it as anomaly detection. So common causes what? Measurement error, data entry mistakes, then genuinely rare event. Rare event means a student scores 100 out of 100 when the class average is 60. This is a real outlier, not an error. Okay. So data entry mistake means typing 2 lakh instead of 20,000 for a salary. Then measurement error, a faulty sensor records temperature as 500 degrees Celsius when all others show 25 degrees Celsius. Then fraudulent activity, a credit card suddenly used in 10 different countries in 1 hour. So these are the causes of outliers. So what are the detection methods? Statistical method, distance-based method, that is KNN, density-based method, LOF, local outlier factor, and machine learning methods. So best example is a bank account typically sees transaction of 500 per day. Suddenly, a 2 lakh withdrawal appears. This single transaction is isolated far from the cluster of normal 500 transactions. See, every day there was a transaction for only rupees 500. Suddenly there was a withdrawal of rupees 2 lakh. So this single transaction is isolated far from the cluster of normal 500 rupees 500 transaction. So outlier detection algorithm flags this for fraud investigation, potentially saving the customer from losing the money. Okay, sometimes outliers are the most valuable data points. In fraud detection, the outlier is the fraud. In medical research, an outlier patient might have a unique genetic mutation. In business, an outlier salesman might have discovered a revolutionary new technique. So always investigate outliers instead of simply deleting them. Applications of cluster analysis. See, cluster analysis is one of the most versatile data mining technique used across nearly every industry. So, we have 6 key application domains. First one is market segmentation. So market segmentation means grouping the customers based on behavior and preference. Like we will have luxury buyers, budget shoppers, right? So in this form we can form the customers as clusters. So each group see different ads and recommendations. Second one is medical diagnosis. So we can identify the patient groups and disease patterns. So you can cluster the patients by symptoms, lab results, then medical history. So this will help the doctors to identify which treatment works best for that group of patients. Okay, so it enables the early detection of disease patterns. A real example, COVID-19 research. It used clustering to identify patient subgroups, right? And third one, image processing. Object detection and image segmentation. How cluster pixels by color, texture, or spatial proximity. And the next one is fraud detection. So identifying the unusual transaction pattern. It catches the fraudulent activity in real time before significant damage occurs. So credit card companies use this DBSCAN to cluster normal spending patterns. So any transaction that falls outside all clusters is flagged for review immediately. And the next one is social network analysis. So here community detection and influence mapping, like how cluster users based on connection pattern, etc. For example, Facebook, LinkedIn, Twitter, they use clustering to detect communities, group of users who interact frequently. This helps in content recommendation and identify the influences. And next one is document classification. So organizing text content by themes, like cluster documents using word embeddings to represent text or vectors. Cluster similar documents together. So for any application or question in your exam, always state the domain, what is being clustered, then the benefits of clustering. So let us see a quick recap. So cluster analysis fundamentals. What is clustered? It groups similar objects without labeled data. That is unsupervised learning. It discovers hidden patterns in complex data sets. And it is essential tool for exploratory data analysis before applying supervised learning. And we have 4 primitive clustering approaches, that is methods. What are they? Partitioning, hierarchical, density-based and grid-based. So under partitioning we have seen 2. One is K-means and K-Medoids. So it will divide the data into K-fixed groups and it is best for compact spherical clusters. Then in hierarchical we have seen 2. One is agglomerative, another one is divisive. So agglomerative means bottom-up merging. It creates dendrogram, no K needed upfront, and it is flexible cut point. And divisive means it is top-down splitting. And it is good for hierarchical data structures. And the third one is density-based, that is DBSCAN. It finds dense regions, any shape clusters it uses, and it auto-detects the outliers as noise. And no K value is needed. And the last method is grid-based. So here they use an algorithm called Sting. It divides the space into grid, works on cell statistics. Very fast, best for huge spatial data sets. So the modern applications, outlier analysis enables fraud detection. And we are using in e-commerce, retail, then medical diagnosis like disease pattern, and image processing like object detection, and in social network analysis like mapping communities and influence in digital platforms. Then document classification enables automated news grouping and search optimization. So you may get questions like explain the K-mean algorithm with all 5 steps, what are its limitations, and what is dendrogram, how do you read it, compare agglomerative and divisive, then explain DBSCAN, what are the two key parameters of DBSCAN, what are the advantages of grid-based, then they may ask you to define outlier, then you can compare all the flow clustering methods using a table. For your understanding purpose, you can make it as. So that's all about this lesson. Thanks for watching. We'll catch up in the next video.